A Levels P1 paper October November 2019. Paper is 1-2. The question number is 5. The diagram shows a solid cone which has a slant height of 15 centimeter. This one slant height is 15 and a vertical height of 8 centimeter. Now this vertical height is 8 centimeter. Show that the volume V centimeter cube of the cone is given by V is equal to 1 by 3 pi bracket 225 H minus H cube. Here the volume of a cone of radius r and vertical height h is 1 by 3 pi r square h. The formula for volume is given to you. Now as volume of the cone is 1 by 3 base area, which is this one, the circle is the base in this case, into height of the cone, which is h, this vertical height. So that is equal to 1 by 3 pi r square, which is area of base, into height. So 1 by 3 pi, now r here is 15 square minus h square. This is value of r square. Now if you consider this a right triangle, this one, this is h, this is r, and this is hypotenuse of this right triangle, which is 15. So hypotenuse square mean 15 square is equal to r square plus h square, this one. So from here you can get the value of r square equal to 15 square minus h square. So in place of r square you can use 15 square minus h square. Now 15 square is 225 minus h square, multiply h, this one, in the bracket. So it will become 225h minus h cube, hence proved. Question number 5 part B. Given that h can vary, find the value of h for which v has a stationary value. Determine, showing all the necessary working, the nature of this stationary value. Now from part A, v is equal to 1 by 3 pi bracket 225 h minus h cube, that is equal to 1 by 3 into pi. Now for stationary value, as you know that stationary point is a point where gradient is 0. So take derivative of v with respect to h. So dv over dh, now this derivative represents gradient. So dv by dh is equal to 1 by 3 pi into d over dh of 225h minus 1 by 3 pi into d over dh h cube. Now I haven't involved 1 over 3 and pi in the differentiation process because they are both constant. Here h is variable, so I am taking derivative of h here in this case. Now from here 1 over 3 pi and 225 will not be affected. However, derivative of h with respect to h, that is dh by dh, is 1 minus 1 over 3 pi. Derivative of h cube with respect to dh or with respect to h is 3h square. By the rule of the derivatives, the power is 3. You have shifted the power and you have decreased the power by 1. Now this is dv over dh. At stationary point, the value of the gradient is 0. So equate this equation, the equation of the derivative, equal to 0. From here you can simplify this equation and you can find the value of h. Now 225 divided by 3 will give you 75. Now from here you can find value of h. This 1 by 3 pi 3h square will come on the left side, it will become plus. Now 3 and 3 will be cancelled, so pi h square is equal to 75 pi. From here h square is equal to 75, as pi and pi will be cancelled, so h will be equal to under root 75. Now we need to find we need to find the nature of the stationary point, because they have asked us to find the nature. So now the derivative was dv over dh equals to this one. So we have to take the second derivative in order to determine the nature of the stationary point. So when you will take the second derivative, mean you will differentiate this equation, which is the first derivative. You will differentiate this equation again. So when you will take derivative of 225 into 1 by 3, both are constant. So derivative of constant is 0 minus derivative of 3, and this 3 and 1 over 3 will be cancelled. So derivative of pi h square, now pi is constant, so we will take out pi as it is. Derivative of h square will be taken, so the power of h square is 2, so 2 will be moved here downwards. Pi is present already here into, now the power of h will be decreased by 1, so 2 minus 1 is 1. Minus is already present over here, so second derivative is minus, which means it is less than 0, and when second derivative is less than 0, so the point is maximum, which is the nature of point in this